just acknowledging that I've gotten a note from a couple kids that's like, oh, I may need to come in and get some extra help because I'm struggling with this stuff. And these are complicated word problems, and that's always been scary since the beginning of time. Like there's comics about word problems from math in high school. Okay, so yeah, it's a little scary, but I'm trusting that you're going to stay with me for today, and tomorrow is all practice and review. And then so far, I've taught you everything. We just get to practice it now today and more tomorrow, and then the test is Wednesday. All right, and then worst case scenario, if it goes bad, yep, it's coming. It's coming quick. If it goes bad, well, you have a retake that you can take called a cumulative, and that takes a while to get there because we just had a cumulative recently. But I think that we are going to have just as good a grade average on this test as we have on all the previous tests, which usually is an A- average in this class. It's going to be fine. You're just right this second. I've been teaching you the hardest problems since day one. Like that makes for it being a little bit scary at the beginning, but once we've had some more practice, you'll be fine. All right, so here's some real basic skills that we would expect you to know. If I said y is less than 3, do you remember how to graph that? Take a second. Graph that. Now, if you get confused on whether these are up or down or left or right, here's the way to do it. So the x-axis is here, but that's not x equals 0. It's what? Y equals 0. And so if that's y equals 0, you'd probably pretty quickly make the judgment that y equals 3 must be like up here. And since it's y is less than 3, hopefully remember to shade underneath it. And there's one more little thing to check for. Is this supposed to be dotted line or a solid line? Dotted. All right. So I'm making it a dotted line, taking some out. Does that make sense to you so far? All right. Now what if I said on the same axes, graph x is less than 4? Actually, let's make it less than or equal to 4. Well, if y goes across like horizontally, then x must go the other way, up and down. And if I go 4, it must be like over here. How come I'm using a solid line? Because it's or equal to, yep. All right, so then less than is shading this way. And usually, if this is a problem about the real world, we have 2 more constraints. Would you please add 2 more little equations that you should know about the real world? Like if we're building widgets or we're selling iPads, what kind of number can't you have? Negatives. So therefore, x has to stay what? Greater than or equal to 0. That's called a common sense constraint. And how about y in the same way? Isn't y also going to need to stay greater than or equal to 0? Okay. Given all that, do you see why that box right there would be the feasible region? Okay. So let's say that this was about iPads down here. Along the x-axis, that's iPads. And let's say that this is iPhones along the y-axis. Maybe this is you personally are out selling these things on the street. People do sell iPads and iPhones out on the street. Usually, they're hot, meaning somebody stole it and now they're going to try to sell it to you. And I would not do that because Apple has a way of knowing if something has been stolen. They can just shut it down from afar, so it just never works. So you might think it's going to work. You buy this iPad from somebody that's going to be like way cheaper than normal, and they just shut it down from afar. All right, that spot right there, would you agree that would be 4, 3 in our scenario? Okay. All right. So now, one side note don't stress about this, but if I made this solid again, it would only make one tiny change to the graph. I'd like to do that. Make that a solid line again. We needed to talk about when it's dotted, but I want it to be solid in both directions. So I just had to make one little change. They're both or equal to, so they're both solid lines. The reason is technically that wouldn't be a point. If it was an intersection of a dotted line and a solid line, we wouldn't do that to you, so I don't want to do it to you now. Okay. Now, the only end of this problem would have been optimize it. So I'd have to give you some more information that isn't even on the graph. And that might be, if you're selling used iPads out on the street, let's say that you make a profit of $50 for each iPad. Profit meaning like what you bought it for, what you sold it for, you made money, right? $50 a profit for those. iPhones, let's say you can make $100 for those. Then the ending of the question would be list the vertices and find the max profit. That is a typical question from beginning to end. So now let's see. I think you can see that this is like a rectangle, so there are 4 corners. I did say that you weren't going to have to figure out what 0, 0's profit is because we all know what the profit would be at 0, 0. So you can skip the origin. That leaves you down to 3 vertices. One of them is 4, 3, but there's 2 other ones. And figure out the profit for each. And if you're like, but I don't have an equation to figure out the profit with, you're supposed to make that equation. And that comes from the 50 and the 100. And that's an optimization equation. Profit is blah, blah, blah. All right, now I want you to finish this problem with a partner. These 2 rows, you're going to work on a bunch of problems together in a minute. Slide next to each other, 6 inches apart. These 2 rows, slide next to each other, 6 inches apart. Brandon, you guys both done already? Compare yet? Okay. The 100 is the Y, by the way. Just to clarify, the iPads are on the bottom, so they're the X. And the iPhones are up here on the Y-axis, and so the Y's are with the 100. So you get your optimization equation before you go too far, because, in fact, you need that first. Okay, your optimization equation has an x and a y in it, and almost all your equations just are like x plus y. They just might have a number on the front of them. So, in this case, is there a number on the front of it? Yeah. For each x, it's 50. And 100 for each y. I'm going to move my plus sign over a little bit. And then I'm going to stick in the 4, 3. I know that's where the max is going to be. I mean, I can just look at it and tell. But you're still going to have to show that it was 4 times 50 is 200 plus 3 times 100 is 300 makes 500. Did you guys get 500 max profit? Cool. If you could make 500 bucks a day, would that be pretty good? Yeah, if you're just a person out there working on the streets trying to make a living. People do this. People actually go door to door and sell things. Some of the most rich people in the world now actually started with that kind of a job. Get good at sales, you can do a lot of things. It's really hard because you got to be able to be rejected a lot. Okay, so then this is my y is 3, so I know that one is supposed to be 3, 0, comma 3. So that's one of my points. And that would lead me to 0 times 50, which is 0, plus 3 times 100 is 300. So that one's worth 300. And then this profit center over here would be at 4, comma 0, 4, comma 0. So 4 times the 50 from this, 50 times the 4 is 200, but you have 0 of the other. So that one adds up to 200, of course. So then the max profit is right there, and we probably knew that was coming. Okay, cool. Do you get that that's what your test is like? All right. You get a problem, and honestly, if all we did is give you 4 really hard word problems, that would be too hard. Because you'd have to get 3 out of the 4 really hard word problems. So how your test actually looks is on some of the problems, we've already created the graph. And like, here's the graph, and we shade it all in here, and we say that's the feasible region. And then all we ask you for on a problem like that might be, what are the vertices, and which one makes the most profit? You know, because what if you graphed it wrong, and then the whole rest of the problem is going to be wrong? Are there a couple where you got to do it from beginning to end? Yes. But there's also a lot of them where they did most of the problem for you, and now you just have to like take it from there. Like on another one, you don't even have to like figure out which one wins. You just have to graph it. You graph one that goes this way and one that goes that way and another one that goes that way. And we just make sure you graphed it right. You shade a little bit here and shade a little bit there and shade a little bit there. So some of the problems are just graph it. Some of them are take the already graphed problem and find the optimization. All right. So what I want to do now is we have homework, which is 3 problems. The first one is just gross. It is so hard. So I want you to take some time, and you got a partner now, right? And I want you to do problem 2 together from start to finish, but I'm going to give each of you a piece of graph paper. And I want you to have everybody, like not just one, the person with the better handwriting, we're going to get each of you make a graph, a nice graph on graph paper that does problem 2 out really nice. Okay, so find the homework for today, find problem 2, work together. I'm going to give each of you a piece of graph paper, and I want you to make sure you do it up really nice. We're taking a break from working on that problem. What type of problem do you think you want to work on? Do you think that it's hardest to make the equations? Do you think it's hardest to graph the equations? Do you think it's hardest to understand like what variable is what? What part do you want to work on?
Making the equation.
Making the equations. All right. You guys agree with that? Yes? What do you think? Okay, and that's a good point. The equations and the constraints are pretty much the same thing. It's just like a different name for the equations. The constraints are constraint equations. All right, so let me give you an example. Let's all do this one. And again, I'm going to just read you a story, and I want you to take a second, and on the back side of your graph paper, just use a little corner of it to make the equations for this, and let's see if you get the right ones. All right. So there's a play happening at our school, like right now? What's the play that's happening right now? Anything goes. Okay. So let's say that you were gonna go to Anything Goes. And I believe that in a lot of schools, there's a different price for the adults and the kids. And that helps us have an X and a Y. Okay. So let's say that the adult tickets are going to be $25 and the student tickets are gonna be 10. All right. What's the very first thing that you have to do? Yes.
Assign variables.
Yeah, you got to assign which one's which, and which one did I mention first?
25.
And therefore, that's the X. And the students is the Y. Now, do you have an equation yet? No, all you have is that X goes with 25. It's not X equals 25. Okay, and it's not Y equals 10. I didn't say there was 10 students. All right, but they go together. All right, so what's another thing that we could do on a typical night? We go to the concert, we look at, it looks like there were 200 people at the play. 200 people at the play. Now, can you make an equation? Yes, you can. Please make an equation. And you guys, you should talk about it. Try to figure out what can I do with the 200. I know I didn't tell you everything, but I told you enough to make an equation. All right, let's say another just fact I told you is that they took in 4850 on that night. Now you can write a different equation. In a minute, I'm going to change it to be inequalities, but right now, so far, I've just said equals. All right, and do you live in the real world? I do. That gives you 2 more equations. Write them. They're called constraint equations for the real world. They're called real world constraints. If you don't know what I mean, talk to your partner, see if they know what I mean.
It can't be negative. Can't make negative. So,
All right. Then we have 4 equations now. The 2 I added at the end there were just, they count. I mean, why not get all the points? X is greater or equal to 0, because you can have 0 tickets sold of a certain category, but you can't go negative, right? And Y is greater than or equal to 0. So there's 2 of my 4 equations. Next one, this is really common for people to think this 200, it has to be more complicated than just X plus Y, but no, it's just X plus Y equals 200. That's it. Because I said there were 200 people there. Now, what if I had phrased it this way? There's only 200 seats. Then how would that change this? There wasn't 200 people, there was 200 seats. Then you could say less than or equal to 200 because, and again, in the real world, you might be able to have people in standing room only, but I don't know if they really sell them tickets and stuff, so. Okay, so I just wanted to show you how it could turn into an inequality. All right, and then what's this 4850 number? Well, that's the one where you got to say 25 times X plus 10 for each Y is equal, in this case, to 4850. Who had the 1, 2, 3, 4 key equations right? Raise your hand if you did. Cool. That's all there is to it. It's like that. And if it's not like that, you're doing something wrong. Like, try to figure out what might you be doing wrong. Now, if I was going to optimize this scenario, there's usually you have another set of numbers. So let's say the 4850 in the real world, is that actually pure profit for the play?
No.
No. But let's say they figured out that of each ticket, there is some profit that they're going to make on each ticket. Okay? Let's say that they figure out that on the adult tickets, they make $5 profit. And on the student tickets, they only make $2 profit. That means after all their expenses, they have cash left over at the end, which they can use to, I don't know, buy really cool costumes for their next play or whatever. So now all of a sudden we have another equation. This one's called the optimization equation. Would you please write the optimization equation then? It needs to be an equation. It can't just be this plus this. What would the optimization equation be? Raise your hand if you feel like your group's got this. Okay, you're just afraid to be called out. Okay, how about this? I promise not to call on you. How many of you think there's a 90% chance you just wrote that equation right? Just be honest with me. I need to see if you get this. Okay, seems like you guys generally get it. Then I'll tell you what it is. It's 5x plus 2y, but it has to equal something. If you just said 5x plus 2y, that's not an equation. So just put p equals. Who had an p equals or something like that? Good. That's an optimization equation. Now, do you get that if we actually graphed all the equations I just gave you, it would end up making some kind of a shape? Now, on the test, we will make sure that it's a reasonable looking shape. And what if it goes like this and it shades out this way? I want you to ponder what that means. Do you see the three key spots? Would you have known that those were the three vertices? And what if it just keeps going, though? Well, what does that mean? That means that, for instance, you're selling tickets to a concert that is outside and can hold unlimited people. And then in that scenario, you wouldn't be asking, what's my maximum profit? On that scenario, it'd be one of these three would be like your minimum something, like the lowest amount we can spend on this and that. So if it keeps going, don't freak. That is a possible right answer. It can just keep going in one direction. Like in the real world, is there a limit to how many iPhones Apple could sell next year? Well, there actually might be. There might be because they only made so many, right? But there's pretty much no limit to how much sand you could collect. I know, there's an actual limit to how much sand, but pretty much no limit. All right, can't even say air because there's actually a limited amount of air in the earth, like in the atmosphere. So, okay, I'm not sure what I could say that is actually unlimited. It feels like the number of planets is unlimited. It's insane how many there are. They do not know if it is an ending to how many planets and stars and galaxies that there are. It's so big that we don't even know if there's a limit. Okay, good enough on that. So, is there anything else that you're scared about for the test? Okay, so basically what happens today is you finish the problems that are on the page, and there is a scary one. The first one, it's just scary because it's pretty intense about the equations, but I've given you the key so you can look at it. But I challenge you to try the equations with your partner right now for number 1, and then look at the key. But please, I know some of you have already opened the key, just don't look at it until you're done with number 1 equations, okay? Get the equations done for number 1. Talk to your partner about them. And then your homework is to do these 3. Tomorrow, I mean, the one that, there's nothing new here. Just what you have on your paper. You did problem 2 already, so you're going to do 1 and 3. That's it. But try to work with your partner on number 1 first, okay? And then tomorrow, I'm going to give you some more practice problems. And then the test is Wednesday. All right, that's all I got for you for today.